Hey everybody, welcome to day 7 of our Aquatic Apocalypse. I recently got a water profile or a water report in the mail about my local drinking water, and I made a video that talks about that and the Adopt a Drain program. So here is that video. It's a 2019 drinking water report. You get one of these every year as a homeowner, and what it has is a list of essentially contaminants and drinking water. It has you ions reports and stuff. It basically tells you what's in your drinking water. And in Minnesota here, our drinking water comes from both surface water and groundwater, and that can be contaminated fairly easily. I have adopted a drain, as has Madeline. This is my drain here. You can do this by going to adopt, I think it's adopt-a-drain, adoptadrain.org, and it actually shows you a map of all the drains in your neighborhood. So being our local park, I decided to take this drain. Madeline's drain's right over there, right across the street, so we can watch over our drains pretty closely. I want you to take a look at this drain, if you can zoom in on this. Probably looks like a pretty typical drain. We've got a lot of stuff here that's making its way into the drain. This leaf, and this is a seed pod, this organic matter, if it makes it into your sewer, it becomes food for algae and weeds. It breaks down and it becomes food for them. What happens if we feed the algae and weeds in the lake? Well, the more algae there's in the lake, you know that the lake can get kind of soupy looking. Less oxygen can get into the lake, and then there's less oxygen for not only the plants but also the fish. Additionally, if our drinking water is coming from both surface and groundwater, that could potentially get in our drinking water. It's good that we have good water facility treatment plants to take care of this, but we have to do our part. And one of those parts is just cleaning up your sewer, cleaning up your sewer drain. So in this case, this is a little before. I'll take a quick video afterwards to show you what I did. I'm just going to take all the organic material and make it nice for the water to drain down in. So that didn't take long at all. Looks much better. You can see all the stuff that would have made its way down into the sewer drain there. And there's more work to do, but this drain right here just took us a couple minutes. Now we're going to move across the street, take care of Madeline's since we're here. There we go, Madeline's storm drain is looking beautiful. I should have mentioned earlier that if you adopt a storm drain, you get to name it. One commitment though, they do want you, if you're going to adopt one, to be looking over it for a whole year, a year dedication to a storm drain. Come out once a month, take the leaves and stuff away from the grading, and that's all that's required. So in that video, I talked about a situation that could arise in an urban setting where you have lots of city drains that all kind of spill out to an area that could be contaminated with things that are in an urban environment. Lots of leaves, maybe there's organic waste from trash. Well, in this story that we're working on, this storyline, the Aquatic Apocalypse, we're in a rural environment, and what we have to worry about is things like, here's two things that we're going to focus on in today's lesson. Nitrates and phosphates. Where do nitrates and phosphates come from? Well, in rural settings, that can actually be a situation where you have runoff from agriculture. So you're going to start by looking at some tables that relate temperature and solubility of different substances like nitrates and phosphates. And since it's dependent on temperature, what we have here in this table is the average temperature and rainfall for every month of the year. Do you remember what month the fish kill happened in? Well, that was December. I'm just going to give that one to you. We're going to focus in on December once we get down to question 8 and beyond, because that was when the fish kill happened. But remember, maybe there's something going on in earlier than December, like maybe November. So those are the two big months that we really have to focus in on going forward. And that's the average data that's going to help us with that. In part 2, we're given a couple solubility tables, and they're focusing on the solubility of nitrate and phosphate
at different temperatures. Okay, so the temperatures, you can grab those from the tables up here, and the questions are going to ask you about what's going on at the time of the fish kill, so that'd be December, or 1 month before the fish kill, which would be November. So you can answer those questions yourself. Keep in mind that both of these tables are for 100 milliliters of water. Okay, obviously we're not talking about, we're not practically talking about 100 milliliters of water if it's a big river, but this is just a table to give you an idea of how much dissolves in a 100 milliliter solution. In part 3, we're given the recommended maximum concentrations for nitrates and phosphates, and you're asked, based on your findings from part 2, whether they were at or above the recommended maximum concentrations. Pretty straightforward question there. And in part 4 here, we're actually given nitrate and phosphate concentrations that were released by White River in the month of December. So the month of November was missing, but at least we're given the concentrations for 16 days in the month of December, and then you can make some conclusions based on that.